In this video, we're gonna we're gonna continue our topic of study design, and we're gonna talk about sampling design and bias. And in the next few videos, we're gonna talk about different sampling designs. And in this video, we're gonna focus on a specific sampling design called simple random sampling. In the previous videos, we talked about sampling bias and non-sampling bias. And we said that sampling bias happens due to variation, or sampling error, rather, happens due to variation data values within a population. We can do nothing about it. But non-sampling error includes sampling bias or incorrect selection of our sample that represents the population. And it's caused by the sampling technique that we select. So the sampling technique may negatively impact how representative the sample is. So we want to minimize this sampling bias, and one way to minimize the sampling bias is to employ a procedure that's called simple random sampling, SRS for short. Now, what is a simple random sampling? It is a procedure in which each possible sample of a given size is equally likely to be obtained, and the sample obtained is called a simple random sample. So basically, in a simple random sampling technique, every member of the population has an equal chance to be selected. For example, let's say I have a class of 30 students, and I want to select 5 of the students. In order to employ simple random sampling, I would write each person's name on a separate piece of paper, put those pieces of paper in a hat or in a bag, shake it up, and then randomly pull 5 pieces of papers with names. That would result in a simple random sample. Every person had a chance to be selected. Now, when we're talking about this technique, we have 2 options: sampling with replacement and sampling without replacement. So simply sampling with replacement is when I pull a person's name out of a hat, then I put it back in to the hat so it could be chosen again. In certain situations, it's appropriate. And in other situations, it's not appropriate. And we're going to be sampling without replacement, meaning once I selected one person, that person's name does not go back into the pool to be selected again. That's sampling without replacement. So each member could be selected only once. So in this course, unless we specify otherwise, a simple random sample is done without replacement. Now, why is it important? Because the chances will, the probability of the person selected will be altered slightly when sampling without replacement. To give you an example, if I have a class of 20 students and I'm selecting 5, so when I pull the first piece of paper with a name, the chance of each person being selected is 1 out of 20. I'm pulling out one piece of paper out of 20 possible. Now, if I set that the piece of paper aside how many do I have left? I only have 19 to select from. So the chance of the next person to be selected, any of the remaining people to be selected, is 1 out of 19 now. See how that number changed from 1 out of 20 to 1 out of 19. So the result will be slightly different. Now, when your population is large, very large, and your sample is very small compared to the population, that difference is negligible. So, in basically, when your sample size, which is denoted by um, n, lowercase n, is 5% of the population or less, the difference in result is negligible. So basically, it doesn't matter whether we select with replacement or without replacement. But when that sample size compared to the size of the population is bigger than 5%, then it will have an effect. All right, so let's take a look at the next two examples and think about which method is more appropriate. So the first example, a teacher picks a random sample of 10 students to answer 10 questions throughout the duration of the class. Would selection with replacement or without replacement be more appropriate? What do you think? Here's an answer from one of the instructors. He says that he would prefer to select students with replacement because he doesn't want a student to think that he may not be chosen anymore after he gave an answer. Okay, this is scenario number 2. A teacher picks a random sample of 10 students to attend a conference. So for this scenario, sampling without replacement would be more appropriate because we want 10 students to attend a conference, and if we select the same student twice, there will be less than 10 students selected for the conference. Now, in real world and for real experiments like the Salk vaccine experiment, pulling names from a hat is not very practical. So there are different methods developed for this purpose. So one such method is a table of random numbers. So the way it would be done, we would just choose the random numbers to start with and use this table to pick our participants. But nowadays, even the table of random numbers is very rarely used because we have a random number generators on the computers. So we'll just have a computer to pick our samples. Okay, the simple random sample is the best. It's a golden standard in sample selection. However, it has its drawbacks. It may fail to provide sufficient coverage or may be impractical when the members of the population are widely scattered geographically. So we're going to discuss some other types of sampling in later videos. But for now, let me give you an example of random sampling versus non-random sampling. So the random sampling, I will remind you, is the sampling where every member of the population gets an equal chance to be selected. So in the picture below, we see a classroom arranged in 5 rows, and in each row we have 7 students. So if we pick, in the first picture, you see the depiction of when students are selected randomly. That's a random sample. Now, if I selected the middle row and the middle row like horizontally, middle row vertically, that would result in the same number of students. However, and the same sample size. However, not every student had a chance to be selected, right? So the students sitting in the corners of the class didn't have a chance to be picked. So this is an example of a non-random sample. Okay, so next we're gonna continue talking about sampling design. We're gonna cover systematic sampling.